All right, hello. Today we are going to do an exponent review, so here's a short little video for you to watch. First, let's go over the rules. If I have x to the 0 power, we learned that anything to the 0 power is 1. So I would say that this is 1. If I have something to the negative power, remember I'm going to move it into, if it's in the numerator, I'll move it into the denominator, and it will then have a positive exponent. So x to the negative n power is going to become 1 over x to the n power. If I had started with it as 1 over x to the negative n power, I would end with x to the n power. So remember, it switches depending on where it started. The other rule we learned about, or one of the other rules we learned about, was if I have two powers being multiplied. Well, first let's deal with the numbers, because the numbers are still going to work the same way we've always worked with them. So 2 times 5 is going to give me 10. And if I have x to the m power times x to the n power, I'm going to add those powers. So if I have multiplication and the same base, I end up adding the powers. If this had been like 3 and this was 2, then I would have x to the 5th power. Another rule we learned about was when I have two x's or two of the same bases being divided. So when I have that, again, we're going to treat the numbers the same. So 2 divided by 2 would give me 1. But with my powers, I'm going to have x to the, when I'm dividing, I'll subtract instead of adding like I did with multiplication. So I have 1 times x to the first power, or just x, because the times 1 is assumed, along with the x to the first power is assumed. You could have also solved this by expanding out, so I'd have 2 over x times x over 2 times x times x. And I would cancel out what's on top and bottom, and I end up getting the same thing. I'm just left with one of the x's. Another rule we learned about was, I like to call this power for power, but basically when you have an exponent being raised to another exponent, or you have an exponent on the outside of the parentheses, I'm going to multiply those two. So I have x to the n times n power, or you can just write it as x times nm, and if I had had like 2 and 3 here, that would be x to the 6th power. And one of the last rules we talked about was if I have a parenthesis with multiple things in it, so x times y, I'm going to make sure this n power goes to both or everything in the parentheses. So I have x to the n times y to the n power. All right, so that's a little review of the rules. Let's go ahead and work through some problems. So problem 1 here, I have 6 times x to the 0 power times y to the 4th divided by 2y. First thing I like to do is get rid of the 0 or negative powers. So really I have 6 times x to the 0 power, anything to the 0 power, times 1 times y to the 4th power over 2y. Again, I like to deal with the numbers first. So 2 goes into 6 3 times, or 6 divided by 2 is 3. Notice how I ignored the 1 because 6 times 1 is just 6. Sorry, I didn't say that earlier, but that's why I did 6 divided by 2. And I've got now to deal with the exponents, or the y's. So when I was dividing, I would subtract those powers. So I have, I'm going to erase that and just start it on a new line. It's a little too cramped. I have 3 times y to the 4 minus 1 power, or 3 times y to the 3rd. And that would be my final answer with that one. Remember, you could have also expanded out here and then canceled that way, but that's our little special trick. All right, problem 2. Ooh, I've got another negative exponent, so I'm going to make it a positive exponent by moving it to the top of that fraction instead of the bottom. So really, instead of 1 over x to the negative third power, I have x to the third power times 7 times x to the sixth power. So there's no number to multiply 7 with, so 7's just along for the ride. So I have 7 times x to the, and remember when I'm multiplying variables, I add their exponents, so 3 plus 6, or 7 times x to the 9. Remember, these have to be the same base for me to be able to add them or for me to be able to divide them like I did here. I'm sorry, subtract them like I did right here. Our last problem, I'm going to demonstrate those last two rules. So I have 2x to the second power times 3y squared to the third power. Let's deal with this one. I'm going to make sure that that to the second power goes to everything in there. So I have 2 to the second power times x to the second power. And 2 to the second power is going to give me 4 times just x to the second power, or x squared. Let's deal with this other part that I've ignored for a second. I'm going to have 3 to the third power times y to the, ooh, this is our power of a power. When I have a power being raised to another power, remember I multiply them, not add them. So this should be y to the sixth, not y to the fifth. So I have 27 y to the sixth for that part. So now I can go ahead and multiply, combine variables if I need to. But I've got 4 times 27, and we should probably bust out our calculator for that. It is 108 times, well, I've got x squared times y to the sixth. Hey, those are not the same base, so I can't add them, so I'll leave it as x squared times y to the sixth, and that would be my final answer there. Hopefully this was a good little review for you. Good luck on your review today.